Okay, so let's find the electronegativity of the following. We're going to find hydrogen. Alright, so what we do is we look, and right here, this number here is the electronegativity. So I see that it is 2.1. Now I look at carbon. It looks like it's 2.55. 2.55. Chlorine looks to be 3.16. 3.16. Neon is, if you look, watch this. Hey, it's 0. And remember, electronegativity is how hard an atom pulls on the other atom's electrons in a covalent bond, or in a bonding situation. And since neon doesn't form any bonds, it has an electronegativity of 0. And then phosphorus, which does form bonds, should have an electronegativity, and the value is 2.19. Alright, so what does electronegativity mean? If fluorine's electronegativity is higher than nitrogen's, what does that tell us about fluorine? What it tells us is that fluorine pulls harder on bonded electrons than nitrogen does. So if fluorine and nitrogen are bonded together, fluorine will pull harder on the electrons than nitrogen will. Alright, look at number 3. Let's move this down a little bit here. Alright, number 3 says argon has an electronegativity of 0. What does that tell us about argon? Basically, what that tells us is that argon does not form chemical bonds. It doesn't pull on electrons. Let's keep going here. What is the electronegativity difference between the following elements? And this is really what we're most interested in finding out. What is the difference in electronegativity? Because that's going to tell us what bond type forms. So let's look here. We've got chlorine, which is 3.16, and we have phosphorus, which is 2.19. So when we take the difference between those two values, what we come up with is 0.97. Now we're going to do the same thing for sulfur and phosphorus. So sulfur is 2.58, phosphorus is 2.19. We'll subtract those two to get the difference, and we get 0.39. Do the same thing for oxygen and magnesium. Oxygen 3.44, magnesium 1.31. Take the difference, we get 2.13. And we'll do it again for nitrogen and iodine. Iodine is 2.66, nitrogen is 3.04. Take the difference and we get, let's see, 0.38. Now we want to determine what bond type. Now the deal is, if the electronegativity difference is less than 0.5, it's a purely covalent bond, which means there's equal sharing between the electrons. They spend just as much time around one atom as the other. If it's more than 1.7, it's purely ionic. The electron leaves the one with the lower value for electronegativity and goes to one with the higher. And if it's in between those, if it's between 0.5 and 1.7, we have what's called a polar covalent bond. So let's just see what we've got here. In the case of chlorine and phosphorus, which we did up here, we see it's 0.97. That means it is a polar covalent bond. If we look at between S and phosphorus, we see the difference is 0.39. That's less than 0.5, so that makes it a purely covalent bond with equal sharing. If we look at it for oxygen and magnesium, we see it's 2.13, which is clearly above 1.7, making this a purely ionic bond. The electron leaves the magnesium and goes to the oxygen. And then over here, with nitrogen and iodine, the difference is 0.38, once again making it a purely covalent bond with perfectly equal sharing. Alright, let's move this up a little bit. What type of bond is formed between the following atoms? Well, let's start off with silicon and nitrogen. So silicon is 1.9 and nitrogen is 3.04, giving us an electronegativity difference of 1.24. So the difference is 1.24, making a polar covalent bond. So in this case, here, it's going to be a polar covalent bond. Now the reason I gave this to you is you know, silicon and nitrogen can form in some molecules single bonds, double bonds, or triple bonds. And what's important to note is this: the electronegativity difference is independent of how many bonds are formed, or how many different atoms are attached to the silicon or nitrogen. All you do in this type of exercise is you look, this atom has one electronegativity value and this has another, and that difference is 1.24. Whether it's single bonds, double bonds, or triple bonds, whether there is another nitrogen here and another one here, it doesn't matter. It's always going to be, in all cases, between silicon and nitrogen, polar covalent, because in all cases between silicon and nitrogen, the electronegativity difference is 1.24. Okay, now in number 7, we want to figure out which one of these has a partial negative charge. Now remember, don't be frightened by the symbols for partial negative and partial positive. A partial negative looks like an 8 with part of it missing, and a partial positive, same thing. It's just a, well, that's a terrible positive. It's just a way of denoting the fact that there's unequal sharing. Whoever has the stronger or higher electronegativity value in a polar bond will get to keep control of the electron for longer, and therefore will have a partial, although not completely full, negative charge. So all you have to do is pick the one that has the higher electronegativity value. So here I have chlorine and phosphorus. Chlorine is 3.16, phosphorus is 2.19, making chlorine a stronger electron polar. So in this case, chlorine is going to have a partial negative charge because it's going to keep control of that electron for more of the time. Now let's compare chlorine to fluorine. Well, in this case here, you see fluorine has a higher electronegativity value. So in this case, fluorine is going to develop the partial negative charge because it gets to hold on to the electron for more time than the chlorine does. Now we're going to compare nitrogen and arsenic. Here's nitrogen. Here's arsenic. Nitrogen has a higher electronegativity value, so nitrogen is going to develop a partial negative charge. And finally, we'll do the same thing for phosphorus and bromine. Bromine is 2.96, phosphorus is 2.19. Bromine has a higher electronegativity value, has a stronger pull, so bromine it is with a partial negative charge. Okay, let's bring it all together now. So which atoms in these following compounds, so the oxygen of the fluorine, the oxygen of the chlorine, the oxygen of the iodine, which of the atoms would the hydrogen in HCl be attracted to? Now, what this comes down to is we've got to figure out which of these have polar bonds and what partial charges we have. So the first thing we have to do is take hydrogen and chlorine and compare their electronegativities. So hydrogen has an electronegativity of 2.1, chlorine has an electronegativity of 3.16. That gives us an electronegativity difference of 1.06. Now that means that it is a polar bond, and therefore the chlorine is going to have a partial negative charge being stronger, leaving the hydrogen with a partial positive charge. So what we need to know here is this, that the hydrogen in HCl, so if I have a HCl bond, what I find is that the hydrogen has a partial positive charge. And what that means then is it's going to be attracted to things that have a negative or partial negative charge. So now what we have to do is, in each of these cases, we have to see between oxygen and fluorine, oxygen and chlorine, oxygen and iodine, are there partial charges. So let's start off with oxygen and fluorine. Oxygen has an electronegativity of 3.44. Fluorine has an electronegativity of 3.98. Now that gives us a difference of 0.54, meaning that it is that's a 0.54 by the way, which means it is a polar covalent bond, and in this case fluorine has a higher electronegativity value and oxygen has the lower. So because fluorine has a higher electronegativity value, fluorine is going to establish a partial negative charge, and oxygen will have a partial positive charge. Sorry, my partials don't look so great. That's just so terrible. Okay. Now, keep in mind, opposites attract. That's the golden rule of chemistry. Because hydrogen has a partial positive charge, it will be attracted to a partial negative charge. Opposites attract. Therefore, the answer in this case is fluorine. It will be attracted to fluorine because opposites attract. Let's try the next one. We now have oxygen and chlorine. Oxygen is 3.44. Chlorine is 3.16. And in that case, what we find is the electronegativity difference is less than 0.5. That means that these are non-polar bonds. There's no partial charges. So there's no opposite to attract to. Hydrogen is neither going to be attracted to oxygen or chlorine because neither of them have partial charges. So the answer is going to be neither. Now, there are other forces at work like van der Waals, but we're not going to worry about that for right now. Okay, and then we get to the last one, oxygen and iodine. Oxygen is 3.44. Iodine is 2.66. That gives me an electronegativity difference of 0.78. All right, well, 0.78 means we have a polar covalent bond. So we need to figure out who has the partial negative charge. The partial negative charge goes to the atom with the higher electronegativity. So you notice iodine is 0.26, oxygen is 3.44. Oxygen has a higher electronegativity value, so oxygen is going to establish a partial negative charge. Iodine is going to establish a partial positive charge. I'm so terrible at this positives. And remember, opposites attract. So hydrogen being partially positive is going to be attracted to oxygen, which is partially negative. And therefore my answer in this case is the oxygen. Well, I hope you enjoyed this homework as much as I did. We'll catch you next time.